Refraction occurs because of waves changing speed at the boundary between two mediums. Remember that refraction is a wave changing direction as it transmits across a boundary. We can demonstrate this using a ripple tank, with deep water at one end and shallow water at the other. These lines represent the peaks of the waves. As we can see, as the wave crosses the boundary between the deep and the shallow water, these peaks have changed angle as the wave changes the direction it travels in. The peaks are also slightly closer together, which shows that its wavelength has decreased. This tells us that the waves have slowed down in the shallow water. But why has this caused the wave to change direction? Well, let's break down what's happening here bit by bit. Well, first, the waves approaching the boundary will have the same speed. Let's suppose this black line represents some sort of boundary, and these dotted lines represent the path of a wave. Notice that this isn't just a single line. The wave has some kind of width. This could be something like the width of a torch beam or the width of a ripple tank. Like in the tank, we can draw in these lines to represent the peaks of the wave. Again, these have some kind of width, and at all points on these lines, the wave will be at the same point in its cycle. You may hear lines such as these referred to as wavefronts, but this term isn't used much at GCSE. Drawing these lines also tells us the direction of the wave, as the wave will always move perpendicular to these lines. You don't need to know why, though. So what happens to these lines when the wave reaches the boundary? Well, as each peak reaches the boundary, not all of the points on the peak will slow down at once. Let's imagine we're looking at 3 points on one of these lines as it moves towards the boundary. Now notice that these won't reach the boundary at the same time. The bottom point will cross the boundary before all of the others. If the wave is going to travel more slowly in the new medium, then this point will slow down first. Let's continue watching this motion. The top 2 points move at the same speed, but the bottom point travels more slowly and travels less distance. Now the middle point has reached the boundary, meaning it's about to slow down and match the lower speed of the bottom point. So the motion continues with only the top point moving at the original speed. It's the last point to reach the boundary, so it will be the last point to slow down. So what's the result of this? Well, have you noticed that the line formed by the 3 points has changed? What does this tell us about the motion of the wave as a whole? Well, the speed of the waves is slower and the direction of the wave changes after the boundary. Let's go back over what we've just seen. The waves initially approached the boundary, travelling perpendicular to these lines called wavefronts. Then at the boundary, different parts of the line slowed at different times, causing the angles of the lines to change like this. But remember, we said that the wave has to be travelling perpendicular to these lines. So if the angle of these lines have changed, then the direction the wave's travelling in must also have changed. So we see the wave now travels in this direction like so. Make sure you have a good understanding of this explanation, as you may be asked to explain this in your exam. For this type of question, it may be useful to draw this diagram to help with your explanation.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy-to-follow videos, and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!